What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. What we're going to be learning about today is 9.2 special right triangles. So we're going to be able to find side lengths in special right triangles, a lot of simplifying some radicals, so make sure you're well versed in that, and then solve real life problems involving special right triangles. We're going to start off right away with a theorem. The first theorem we're going to talk about today is the 45-45-90 triangle theorem. That just tells us if I have two 45-degree angles and a 90-degree angle triangle, the hypotenuse is the square root of 2 times as long as each leg. So each leg you can see here is matching. The hypotenuse is just the leg x times the square root of 2. Okay, so we're going to apply that in these. These are showing that we have a 90-degree angle and two 45-degree angles, or a 90-degree angle and two matching side lengths. So what we're going to do is try to fill out and solve for x. Okay? The first one is pretty easy for us because we know that the hypotenuse is just the length of the leg times the square root of 2. And if we look right here, x is equal to 2. So no solving had to be done here. However, for the next one, we notice that our legs, leg here, are the square root of 2, and the hypotenuse is just our leg times the square root of 2. So here's our leg, and then times again by the square root of 2. This is going to give us the square root of 4, which is equal just to 2. So y is equal to 2. Okay? For this question, we can assume that if this is 45 degrees, this is 45 degrees, which means 8 and 8 should be matching. And again, if our legs are 8, we're just going to take our leg, 8, and multiply it by the square root of 2. We can't simplify that anymore, so x is equal to 8 times square root of 2. And then for our final one, we look at our legs. Both of them are labeled x, and again our hypotenuse is labeled as take our legs and times it by 2, and all we see is x has just been replaced by the number 5. So x has been equal to 5 for this final one. Okay? The next one we're going to see is very similar, except for we're talking about 30, 60, and 90-degree triangles. So in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg. So here's the shorter leg, and hypotenuse is showing 2 times as long. The longer leg is the square root of 3 times as long as the shorter one. So that's why we see x square root 3 for the longer leg. Okay? So these two things would be great to write down in your theorem sheet, copy it down. You might even want to draw this picture here, just so you kind of have a visual of what that looks like. What we're going to do now is try some of these. It says, find the value of the variable, write your answers in simplest form. So basically what we're doing from here, by hypotenuse, I'm going to just write h here. Hypotenuse is shorter leg times 2. So we'll say short times 2. And your long leg is going to be equal to short times square root 3. Okay? So we look at the first one. The first one shows us we have 60 degrees, 30 degrees, and 90-degree angle. According to our angles theorem, we know that the angle across from a leg of a triangle is going to be the shortest side. So since 30 is the lowest number, we're going to say square root 3 is short, which means x would be long. Okay, so all I got to do for long is take my short leg times 3, and then, times square root of 3, and then times square root of 3 again. That gives us square root 9, which is equal to 3. So x is equal to 3 for this first one. Okay, here we're seeing a few different things. For this one, it's labeled h in the middle, so we can assume that that's our hypotenuse. So that just means whatever my short leg is, I'm going to multiply that by the square root of 3. Oh no, sorry, that's just the height. So our hypotenuse is 4 because we're seeing that's across from the 90-degree angle, but this h is standing for our long leg. I don't know why they labeled it. Maybe they labeled it as height and I just forgot it was not hypotenuse. Okay, so my long leg is whatever the short side, which is 2, times the square root of 3. That cannot be solved, so h, our variable we're solving for, is 2 square root 3. Our final piece, we see our short side is letter x, and our hypotenuse is letter y. So let's talk about our short side first. Our long side is short side times square root 3. So long side is 9, but I know if I take my short side and times that by square root of 3, I'm equal to 9, okay? So what I'm going to try to do here is maybe find a radical and solve for x. So I'm going to divide both sides by square root 3. So I'm going to get x is equal to 9 square root 3. Now, if you have learned this in the past, you cannot have a radical on the bottom. So what we've done before is if we have simplified by multiplying both top and bottom of a fraction by the radical. Okay, so on the top, I'm going to have 9 square root 3. And on the bottom, if I do square root 3 times square root 3, that's equal to square root 9, which is just equal to 3. Okay, then I can simplify a little more. If I'm looking at 9 and 3 as a fraction, 3 can go into 9 3 times, so my final answer is 3 square root 3 for letter x, okay? So, if x is 3 square root 3, my hypotenuse can be found by taking that short side times 2. So, short side is 3 square root 3 times 2, and all I can do here is multiply my numbers that are normal. 2 times 3 is 6, so I get 6 square root 3 for my hypotenuse, or my y. Okay, that one was kind of long, kind of extended out over here. All right, a warning sticker is shaped like an equilateral triangle with side lengths of 4 inches. So let's start by drawing that. 4, 4, 4. Estimate the area of the sticker by finding the area of the equilateral triangle to the nearest tenth of an inch. So I'm going to kind of set it up like what I saw here. Notice that this is an equilateral triangle because 4, 4, and then this one would also be 4. So I'm going to break it up by having this be 2 and 2. So you can even think about it as 2 smaller triangles. But we want to be able to find the height. So what we're going to do here is consider maybe one of these as a triangle, okay? I'm going to say that this is 2, so across from 2 should be 30 degrees, this should be 60 degrees, so we're looking at that kind of a deal. If this was all equilateral, then all would be 60, but since we're splitting this big angle here into 2, that's going to be a 30 degrees, so we're going to use that 30, 60, 90 triangle theorem, and according to that, my hypotenuse is short times 2, and then my long leg is going to be short times square root 3. Okay, so my hypotenuse has already been found for me. That's 4, so 4 is equal to my short times 2. Okay. But my height is really what I want to know. So this height, which would be your leg, that's your longer side. I'm going to have to multiply short times 3. So h is equal to my short side, which is 2, times square root 3. Okay? So if h is equal to 2 square root 3, to find my area, remember for area of a triangle, I'll do 1/2 base times height. So I'm going to do 1/2 base is 2 times height, which is 2 square root 3. Okay? Now, what I'm going to do is kind of look at a few things here. I want to know first, how can I simplify this? So we've got 2 times 2, which is 4. So that's 4 square root 3. And then I'm going to take a half of that. Here's where you'd really want a handy dandy calculator. So what we're going to do is kind of look at how that can be shown. Okay. So what you can do is you can take square root 3, which is a long number, it's about 1.73, times that by 4, and then divide by 2. Okay, and I'm getting about 3.46 inches, roughly. If you want to round it to 3.5, you can do that too. Okay. A tipping platform is a ramp used to unload trucks. So cool. We know a ramp is probably in the shape of a triangle. And it says how high is the end of the ramp of an 80-foot ramp, so 80 feet. Don't know how high it is, or we could say that's our height. Okay. When the tipping angle is 30 degrees, and then we'll do another one that's 45 degrees. So since this one is 30 degrees, we're going to use the 30, 60, 90. We know that our hypotenuse is 2 times the shorter side, so that'd be 2 times x. Okay, so hypotenuse 2 times x is equal to that 80 feet. So in this case, x will be equal to 40 feet. Okay, but now I want to talk about if it's a 45-degree angle. So still got my triangle going on, not drawn to scale, but here's my 45-degree angle. And if I'm going to use that 45-degree theorem, I know this is 80 degrees, but I want to know what is going to be one of those legs. And if I look back at this, my legs are equal to, my hypotenuse is 2 square root 2 times as long as each leg. Okay, so if I don't know my leg here, but I know that that is going to be 2 times as long, square root 2 times as long as my hypotenuse. So I'm going to set x square root 2 is equal to 80. I'm going to divide both sides by square root 2. So I get x is equal to 80 over square root 2. But since this is irrational number on the bottom, I'm going to multiply both bottom and top by square root 2. So I'm going to have 80 square root 2 over square root 2 times square root 2 is just going to be 2. Okay? Then I can look at 80 and 2, and those can be simplified one more time. Get 40 square root 2 feet. Okay? That is going to conclude our work today on 9.2. Thanks for tuning in, and hopefully this video helped you. Give it a thumbs up and let me know if anything else you'd like for me to see. Tomorrow or next time, we're going to be going into lesson 9.3, which is the similar right triangles. Have a great day.